afternoon, Mr. Ike.
Yeah, good afternoon. Sit down. You're welcome.
Thank you, sir.
How's your day going?
It's been going good.
Okay. You're welcome to this class. Today's class we'll be looking at the principle of moments. The principle of moments. Okay? Principle of moments. In our previous lesson, we looked at vectors, scalars, and vectors. And then I introduced you to equilibrium of forces. Is that also?
Yes, sir.
Yeah, equilibrium of forces. So we said that forces balance each other. So in today's class, we are going to extend our knowledge on equilibrium of forces, and we extend it to what is known as the principle of what? Moments. Now, basically, I will just state what the principle of moments is all about. The principle of moments simply states that, you can write it down, that the sum of clockwise moments is equal to the sum of anti-clockwise moments. And the sum of clockwise moments is equal to what?
Sum of anti-clockwise moments.
In addition to that, you can also say that the sum of vertical forces acting upwards is equal to the sum of vertical forces acting downwards. So these two ways they speak on the principle of moments. Now, let's say for instance, I have something like this. Okay, this is just like a normal bar. It can be anything, a bar. Okay, it can be a meter rule, it can be anything. I'm just drawing a rectangular shape. Something like this, for instance. I don't know how many of you are familiar with something you learned in when you were in junior school, or primary school, where you play with a swing, a seesaw spring. Can you remember?
Yes, sir.
So we play with things like that, where one person will stand somewhere here, another person will stand here, and then when the person comes here, this one goes up. If nobody is there, but if someone is there to balance the person out, something like that.
Yes, sir.
So that principle, the science behind it, is what we want to look at in today's class. Without knowing, you are already applying the principle of moments. Okay? Which states again that the sum of clockwise moments is equal to the sum of what? Anti-clockwise moments. What do you mean by clockwise? Clockwise means something moving in the direction of a clock. This is the board, for instance, now. And I want you to say the direction of a clock. It will go this way. Isn't that so?
Yes,
so this direction is the direction of the maybe the second hand or the main hand of a clock. This is a clockwise moment. Now, anti-clockwise moment means something that is going this way. Okay? Now, when we say moment, what do we mean by moment? Moment simply means the product of force and distance. So, in other words, moment is just the multiplication, the product of a force and what? Distance. So, force times distance. Force times distance. That is what the moment means. So, when we say clockwise moment, we are saying the product of force and distance in a clockwise direction. Then if we say anti-clockwise moment, then we're talking about the product of force and distance in a what? An anti-clockwise direction. So to demonstrate the principle of moments, we have some apparatus that will help us. This one is called a meter rule. It's called a meter rule. The length from here to here is 1 meter or 100 centimeters. Then we have this here. This is called a pivot or a knife edge. We call it pivot or knife edge in physics. Okay, just like a triangular slab. Then we have some masses here. We have a couple of masses here. They have different weights. This is 20. This is 50. This is 50 again. This is also 50. So we'll just use them to demonstrate our principle of moment. Let's understand what the principle is saying. For instance, if I have my pivot, that's this one now. If I have this pivot and I place it this way, and I have a ruler acting here, if I place a mass, and let me say I place a mass of 50 gram, I place a mass of 50 gram. The weight of the mass is always the weight of the mass is always acting downwards. So this will come down like this. So I have two options I can do at this point. I could either convert the 50 grams to weight, or I leave it like that. For now, I'll leave it that way. I don't need to convert it to weight. In our SS1 class, we learned how to convert something from gram to kilogram. Isn't that so?
Yes.
How do you come from gram to kilogram?
Divided by 1,000.
We divide by 1,000. But for now, let's just leave it the way it is. Now, if this is a 50 gram applied to this, and I have a distance from here to here, okay, let me say the distance from here to here is actually, let's call it 35 centimeters. For instance, 35 centimeters. And I have another mass here, which I apply here, and the mass, because I'm drawing this arrow down, because the weight is always acting downwards. The weight is always acting downwards. Let's say the mass here is 70 grams, for instance, 70 grams. If the mass is 70 grams, you might be required to find what distance will be required to balance this thing on the meter rule. Okay? So, on the distance here, let's call the distance x. So, to determine the distance, we have to identify the clockwise and the anti-clockwise moments. So, from here, this is how you do it. From the tip of this arrow, you will draw a curve as if it is coming to the pivot. The pivot. So, like this now. This is a curve coming towards the pivot. What direction is this? From what I showed, is it clockwise or anti-clockwise?
Anti-clockwise.
Anti-clockwise, right?
Yes.
So I'll write this there. ACW. ACW here will represent anti-clockwise. Okay? Then we have another one again. Vanessa. Stay well. Focus. So if we look at the tip of this, from here to here, we will draw another one from the tip of this arrow as if you are going towards the pivot. Okay? What direction is this, please?
A clockwise direction.
This is a clockwise moment, right? So I will write it there. Clockwise moment. Can you see it?
Yes.
So we now have two symbols here. We have the anti-clockwise moment and the clockwise moment. So let's calculate the value of the anti-clockwise moment, because according to the law of moments, it says that the sum, this is the symbol for summation, you know this already from mathematics.
Yes,
The sum of clockwise moments is equal to the sum of anti-clockwise moments, right?
Yes,
so
sir.
my clockwise moment is what? 70 times what?
X.
So 70 times x. Mind you, this 70 is in grams. I can convert this 70 to a force, like we were talking about here, if I wanted to. And how would I have done that? I'll first of all need to convert 70 grams to kilogram, right?
Yes, sir.
By dividing by 1,000.
Yes, sir.
And then I'll multiply by g, gravity, which is approximately 10. But for the context of this question, let's leave it to because in some questions, they may just ask you for the mass or the distance. So in this case, whether we have converted it to the force or not, we will still get the same answer. So let's just stick with this for now. So this will give me my 70 grams times x, right? 70 grams times x. While my anti-clockwise moment is what?
25 times 50.
That's 50 times 35, thank you. Times 35. So to get my x distance, I make x the subject of the formula. So that will be x is equals to 50 times 35 over 70. So help me. What answer me? 25. So 25 centimeter. So it means that my 70 gram force has to be placed 25 centimeter from the pivot point. Is that clear?
Yes, sir.
Okay. So what we have here before us is my meter rule and my pivot here. Maybe you will come forward. Let's see whether we can balance this thing. Let's put one at 35 and put one at 70 and see how close to reality we may come. So come closer to the front. Come to the front. Come to the front. So this one is approximately 50, not exactly 50, but approximately 50. This one is 20. So 50 and this one is also 50. So 50 and 20 here will give me 70, right?
Yes.
So let's balance our meter rule at 50 first. Then we put one of them first. Let's put this one. And let's balance the one that is
7.
no. The one that is 50. Let's balance it 35 centimeters from this point. So if here is 50 Oh yeah, 35 from it will be what? Like saying 50 minus 35 to get us the reading from here. Where will you balance it?
15.
15, right? So let's do it by yourself. Locate 15 and balance this one. No, let this one be on 50. Let the pilot one be on 50. Yeah? Oh yeah, balance.
270.
Put this one on. See, you have to stand vertical this way to avoid error due to parallax. So your eye level should be facing like that. Oh yeah, attempt it. So is it on 50 exactly?
Yeah.
The middle of this one should be on where? 15. You said 15, right?
Yeah.
Wait. Where is our 1 starting from? This is 0, right? So your 15 is, you are reading from here. Are you getting it?
Yeah.
So this one is not on 15. So you have to move it to the point where you have 15. Oh yeah, move it now, move it. Okay? So that means it's around 15, right? The midpoint around 15. So the other one that is 50, this should be around 50. Okay, that one too should be 50. You can use it to balance it. So now we want a situation where this is what we're trying to achieve. Hold on. We want a situation where the two will be balanced for some seconds. Okay? Like in this case now, this one is still having the upper end. You can see where this side is pressing down. So you keep adjusting this one until you can theoretically see a point where this thing will be balanced. So try and look at that point. And try and move it back, let's see. Huh? You can go ahead. Wait, it's maybe because our meter will bend slightly. It's moving. Oh, wait. Let's, okay, eh? What mass is that? 50, balance. Shift it towards the right, move it towards the right. No, this one. And it's going up.
Yes, sir.
It's going up.
But it's not enough to.
Still at this rate, it's not. Look at the end, let's see. It's because maybe our meter rate is already bent. That's one of the precautions you take. It's not so straight like that. So you understand? So it's already bent like this.
Okay.
So hopefully when we get another meter rate from the lab, we'll restore it. But already you can see that it's already lifting this one from above. Okay, what we'll do here is let's add more to this one. Let's add more to it. Yeah, try and adjust it closer so that.
Find the balance.
What do you notice that is happening? This is what I want you to see from this. We're looking at the moment, the product of what this gram is producing and the distance from here to here. Observe that by increasing the distance, we're increasing the moment this one has. Now this one is pushing it down, right?
Yes.
But when it is here, can you see that when it is here, the moment is small? Because moment means the force from this one and this distance. Are you seeing it?
Yes.
So it's not enough to press our meter rule the other way. Are you getting it? But if I extend this distance here now, what do you observe? Are you seeing that it's now trying to almost, right?
Yes.
So as you keep increasing this, you are increasing the distance. You are increasing the what? Distance. And once you increase the distance, you are increasing the moment. Because from what we said before, this way. From what we said before, we said moment is equal to what? Force times distance. So there are two things that can increase moment for us. Either the force or the what? Distance. So by increasing the distance from the pivot point, we are increasing the moment. So once the moments on the right and on the left are balanced, the thing will be on the equilibrium. So do it again, extend a little bit. You will see that this side will lift up. So by increasing the distance here, you increase the moment. Now this side is now going up. Yes. So that's the concept we are looking at here. So if all physical factors are in their left constants, you observe that we have a balance between the clockwise and the what? And the clockwise moments. Okay? So do you have any questions based on what we've seen so far?
So at the point where it's balanced, how long will it stay?
It depends. We just want to observe it for some few seconds. So maybe like 5-6 seconds is balanced before one end tilts. Why I say other physical factors is that wind, like here now, like the breeze moving, so it can alter it. But assume that we don't have wind and other factors like that. You can remain stable. But once you see it for like some few seconds, 4-5 seconds should be okay. You use that and you now get your readings. And that would be that your meter will be very straight. Like this one now is slightly bent. And your pivot will be perfect. This one's pivot now is tilting a little bit. But the concept I want to show you there is that the more the distance, the more the moment it was creating, to balance the moment on the other side. Okay?
Yes,
And
sir.
since we did not change the forces, so the only thing we are changing is the distance. Is that clear?
Yes, sir.
Any other questions? Yes, ma'am.
Let's say we were in a practical exam now. It's taking a lot of time. Isn't there just any way we can just find calculations, put it on the exact spot and
What's it? I'm not getting the question.
let's say we're in an exam and our time is limited. Isn't there another way that we can just calculate the exam point we should put it on that to be moving it?
No, if it's a practical exam, you have to carry out the practical. It's not a matter of trying a way to manipulate it. This is science. Are you getting it? It's the figures you will get. In a practical exam, they will give you instructions. They can tell you, for instance, place this one at a particular point. Then they will tell you, keep adjusting this one to a particular distance, then another distance, or they may tell you to be changing the mass in this case. So you'll be acting based on the instruction given to you. From that, you will now plot your table and then your graph. So you will not say because you know that the formula is force times distance, you now look for a way to manipulate your answer. No. You follow the instruction and carry out the practical. What they want to test in your exam is the trend. Okay, they want to see that maybe as the force is increasing, what's happening to something else. They are looking at more as the trend, not at your actual values per se. So you may see the same question, but two people will have different values from it. But your trend will be the same thing. If something is meant to increase, if the distance is meant to increase, if the distance is meant to reduce, that is what the examiner wants to check. Not on whether your exact value is the same, because there can be different factors that can fluctuate. Somebody may have a meter that is not so straight. Somebody might be doing his own near a window that the breeze is blowing. Are you getting it? But in whichever the case, there will be a trend. They're meant to see increase or decrease. That's what the examiner wants to test you on. Okay? Is there any other thing?
Yes, sir.
So we'll continue from there in our next class.